Hi gang, I'll go over the solution to the pilot exam. That was really just to help you set up your computer. This doesn't count as your grade, but I know some of you are curious and want to review this. If the camera goes out of focus, I'll fix it. All right, so this is the function I gave you for the pilot test, and the difference quotient is f of x plus h minus f of x over h. So when you do the difference quotient, the very first thing you want to do, step one, is to create f of x plus h. Now note that you already have f of x. This function right here is f of x. What you need to do is you need to create f of x plus h. And how you do that is you use the f template. This is the f template. So let me just write it over here again for one moment. So when you create f of x plus h, what you want to do is you want to replace x with x plus h. So everywhere I have an x, I'm going to replace it with x plus h. So everywhere I have an x, right now I'll just put like a box in everywhere I have an x. And where that x is, the x now becomes x plus h. Okay, the x becomes x plus h. So everywhere there's an x, it becomes an x plus h. Do not add h at the end. Do not add h at the end. F of x plus h is not the same question as f of x plus h, okay? Substituting in is not the same thing as tagging something after. This would be tagging something after. Don't do that. That's not what I'm asking. That would be this. When you take the function and at the end you add the h. I'm not asking that. I'm asking that you replace into the function, substitute into the function x plus h. Okay, so once you create the f of x plus h, what you want to do is now plug into the difference quotient. So now I'm going to plug into the difference quotient. So first you put f of x plus h in. Now here you have to be careful because you're subtracting all of f, not just the first guy, you're subtracting all of f. So what I tend to do is put a bracket up. So f is 2x minus 3x plus 5. Because you have to make sure you subtract each of these terms, not just the first guy. Okay, be really careful of that. That will screw you up. So this negative has to go, this negative has to be distributed to each of these terms. And this is all over h. All right, and one other little thing I want to point out is x plus h, when you square x plus h, you can't just throw it in. You can't just throw it in. Like some people think this is this. Okay, so notice the difference here. This is x plus h squared. This is x times h squared. X times h squared is a lot easier to do than x plus h squared. X times h squared is x squared h squared because this is a product. This is a sum. This is a sum, which means that it means that you have two of these. Just you do have two of them over here too. If that's how your brain sees it. You do have two here also, and then x times x is x squared, h times h is h squared. But the thing is since it's a sum, this is going to end up being a FOIL. So it's x times x times h, keep it in alphabetical order so you can keep your pattern straight. H times x, h times h. Which then you can combine your middle terms. Okay, so this FOILed is this. You may remember your formula from intermediate algebra. You may remember your formula if you have the summation of a plus b, and that's quantity squared. That's a squared plus 2ab plus b squared. You can also just use that formula to do x plus h quantity squared, okay? Up to you. But I just want to make sure that you get this. All right, so this is going to FOIL. You got to use your PEMDAS, right? This is going to FOIL to x squared plus 2hx plus h squared. This part here will become this. Now you got to use your PEMDAS, right? Your PEMDAS. Right, so you have to do the squaring first and then you distribute the 2. Do not distribute the 2 first. That would be incorrect. You have to do the exponent before you do the multiplication. You have to do the exponent before you do the multiplication. So you have to do this guy first, which was why we got this. Then you do that, all right? All right, so now I can go ahead and put the 2 in. I can put the -3. Now make sure when you put this through, it's a -3 to both. A -3 to both. And like we said earlier, a -1 to all of these multiplied changes the sign of everybody. So on the test, this problem is going to be very algebraically intensive. It's from section 3.1. I'm looking to see all the steps for this. So as you're seeing me solve it, I'm looking for all these little steps. And you can do this. You're very good at this. You just have to practice it and remember how to do it. All right? Okay, so now let's combine like terms. So this and this is a like term, but they're equal but opposite signs, so they cancel out. This and this is a like term, but they're equal but opposite signs, so this will cancel out. And then you also have the 5, a +5, a -5, so that will cancel out. If you've done it correctly, everything left will have an H in it, so you'll notice everything left has an H in it. Okay, I'm trying to say all the minutia detail in here, and if I miss something you want to review or go over, you just let me know. Because math, as you know, adds on itself, and it's important to have the foundation so that you can move forward. All right, so what I did here from this step to this step is I took out a common factor of h. I took out a common factor of h. Since the answer is a fraction, you have to make sure that it's in lowest form. So lowest form can have no common factors. So I'm taking out the h over h, and I'm left with 4x plus 2h minus 3, which is the final answer. Okay, I hope you enjoyed that review. I hope it helped if this was a confusing problem for you. Again, this is section 3.1, so you'll see the lecture videos for this. And if you're stuck on any of them, let me know. All right, gang, I'm going to wish you a happy day. Catch you soon. Bye-bye.